Okay, in this last video in this series, we're just going to do one more example of solving a three-variable system by hand using kind of the longer method, but the very tried and true method of our four different goals of being able to first eliminate a variable in goals 1 and 2, and then solving that system, that two-variable system in goal 3, and then actually solving for our last variable in goal 4. So for the first one, we want to look, and we are trying to find out which variable do we think would be the easiest one to eliminate? So looking at my x's, my y's, or my z's. Honestly, looking here at my z's, I got this 5 and 2 and 3. So I know that's probably not going to be the easiest one to eliminate. I could either easily eliminate x or y. I'm going to choose y because I have 3y here and negative 3y here, which is going to make goal 1 super easy. So I'm going to start by choosing a and c as my goals, or as my two equations that I'm going to start with in order to eliminate y. So I'm just going to take them out to the side. I'm going to label this goal 1, and I'm going to write that entire equation. So negative 3x minus 3y plus 3z is equal to negative 30. And then negative x plus 3y plus 5z is equal to 6. And using elimination, I can combine these. It's going to give me negative 4x. These eliminate because they are equal and opposite. Plus 8z is then equal to negative 24. So I like to add that equation down here. So ABC, which should actually be D. I'm going to label this equation D. Negative 4x plus 8z equals negative 24. This is another one of our equations that is going to be true, and I got it by combining A and C. Goal 2 is by using a different combination of your original three, create equation E by eliminating the same variable. So I can choose A and B, or I can choose B and C, but I have to include B somehow. Personally, I'm going to do B and C, and that's because one's already positive, one's already negative. It's just going to be a slightly less step here. So for goal 2, I'm choosing B and I am choosing C in order to, once again, eliminate that same variable of y. So I'm going to start with 6x minus y minus 2z is equal to 21, and then negative x plus 3y plus 5z equals 6. Now, in order to eliminate, I have to eliminate y, because that's what I eliminated up here. I see that this one is positive 3, so I'm going to multiply the first equation by 3 to make this a negative 3. That's going to give me 18x minus 3y minus 6z is equal to 21 times 3 is a great question here, 63. Okay, I can now go ahead and combine these two. Don't know how I switched to blue there. I'm going to go ahead and combine these two. So 18 minus 1 gives me 17x. Once again, my y's cancel. Minus z is equal to 63, and 6 is 69. So I'm going to come over here and write that underneath E. That is my next equation. Notice you know you've been successful if D and E are the same two variables, so x and z. So I've fully eliminated y, and I now have a two-variable system that I can solve using either substitution or elimination. So I'm going to take these to the side and kind of see what I can do here and start to solve this out. This is going to be goal number 3. So looking at goal number 3. As I get into goal number 3, one of the first things I actually notice is that D is fully divisible by 4. Negative 4 divides by 4, 8 divides by 4, 24 divides by 4. And even though this is not a necessary step, it's often a useful step just to make it down to its least common factors. It just often will make it a little bit easier. So I'm going to divide everything by 4 in this case, and that's going to give me negative x plus 2z is equal to negative 6. Once again, this wasn't a mandatory step, but as I look at whether or not I want to use substitution or elimination, it's just going to help me out a little bit. And by doing that, I see that this actually can come really easy to eliminate. I can multiply my second equation by 2, and then I can eliminate z. So that's what I'm going to do here, multiply it by 2. So I'm going to rewrite my first one, negative x plus 2z is equal to negative 6. Multiply this entire second equation by 2. That is going to give me 34x minus 2z is equal to 69 times 2 is 138. Using my elimination, 34 and negative 1 is 33. 2 and negative 2 cancels out. 138 minus 6 is equal to 132. I can divide those. And I'm going to use my handy dandy calculator on that one because I got some big numbers here. 132 divided by 33 is actually just 4. So I have fully solved for one of my variables. I'm off to a great start. But all of goal 3 is to solve the system completely. So it's to get both x and z. So I'm not going to plug x back in to either of these or either of these up here in order to get that. Personally, this one looks the simplest, so that is where I'm going to plug that back in. So I'm going to say negative 4 plus 2z is equal to negative 6. I'm going to add that 4 to the other side, so I get 2z equals negative 2, leaving me just with z equals negative 1. So I've solved for x, I've solved for y. Goal 4 just says awesome. You've now solved for 2 of your variables. Go back to the beginning, plug them into any of these to solve for your last variable. Personally, the last one, equation C, looks to be the simplest, so that's the one I'm going to do. Do negative 4 plus, I'm solving for a y, so plus 3y plus 5 times negative 1 is equal to 6. So I plugged in my value for x, I plugged in my value for z, and now all I have to do is solve that out. So negative 4 plus 3y minus 5 equals 6. That gives me negative 9 plus 3y equals 6. I'm going to add that 9 to the other side. 3y is equal to 15, meaning y is equal to 5. Once again, just write your final answer as an ordered triplet. That goes x, y, and z. So 4, 5, and negative 1. If you're not sure about your answer, you can always double check by plugging it into all 3 and making sure that all 3 of you give you a true statement. But this was your last one on how you can solve a 3-variable system by hand.